Yes, dear students, good morning. Last class we have discussed about the one type, or that is one category of unsupervised learning. That is what clustering. Okay, that too hierarchical clustering we have discussed. And this video we are going to see about the another category which is named as that is dimensionality reduction. So dimensionality reduction. What does mean by dimensionality reduction? So from the name we come to know that dimension is going to be reduced. Okay, so the same explanation here, it is going to be used in this machine learning and artificial intelligence technology with the help of machine learning algorithms, right? So dimensionality reduction is a type of feature extraction technique that aims to reduce the number of input features while retaining as much of the original information as possible. So here, especially the dimensionality reduction, it is a feature extraction technique. We can observe this to reduce the number of input features. So what are the input data we are giving, that will be reduced so that the dimensionality is going to be reduced obviously. But here the concept behind this, if we reduce the dimension, the outcome, that means the quality of the output will not be deviated. Okay, so that is compensated by machine learning algorithms. So here two algorithms especially used for dimensionality reduction, that too unsupervised learning. First one is principal component analysis, probabilistic principal component analysis. We will see what is PCA and what is probabilistic PCA. First, principal component analysis. Principal component analysis is an unsupervised learning algorithm technique used to examine the interrelations among a set of variables. So first it will examine the interrelations among the set of variables, so that it will come to know what type of input feature is there in which area we want to reduce. Likewise, it will analyze and it will examine the set of variables. Okay, principal component analysis is used to reduce the dimensionality of the data set by finding a new set of variables smaller than the original set of variables, retaining most of the samples information and useful for the regression and classification of data. So here, which means compared to the original set of variables, it is the dimensionality, it is going to be reduced. Okay, so example of it, many applications include data compression, image processing, because data compression, we all know that we can have some video, or we will short some video now. Okay, those video pixels, that is video capacity, it is going to be exceed the storage space. What we used to do, we will compress using compressor, we will make the compress the video so that the space will be reduced. But while compressing the video, the pixels will not get damaged, so that the image quality will be retained. So for that purpose, we will use the machine learning algorithms. Okay, so the examples: data compression, image processing, visualization, exploratory data analysis, pattern recognition, and time series predictions. So in these areas, the machine learning algorithms, that is artificial intelligence technologies, are doing a major role. And what is probabilistic PCA? Probabilistic principal component analysis is a dimensionality reduction technique that analyze data via a lower dimensional latent space. That is, it will specifically analyze, that is using the lower dimensional latent space. Okay, and it is often used when there is missing values in the data or for multidimensional scaling. So one of the biggest advantage of the probabilistic PCA is that it can handle missing values in a data set. Yeah, that is foremost important, because in a data set some data may be missed. That missing data set also handled by this probabilistic PCA based upon its largest, and which is not possible with classical PCA. Here, the description of probabilistic PCA replace the missing values by using a linear model that analyzes the correlation between the columns and estimates a low dimensional approximation of data from which the full data is reconstructed. Okay, so this is how the probabilistic PCA will work. And coming to the application of dimensionality reduction, we are having the major application. I already we had some glimpse, and we will see in detail now. That is financial data. Financial data, here PCA is used to uncover latent patterns and correlation in the financial data. Exploratory data analysis and predictive modeling. Principal component analysis is used to visualize complex data set, reduce computational cost, and avoid overfitting. So that is why exploratory data analysis and predictive modeling, this dimensionality reduction is used. And coming to this image and video processing, dimensionality reduction is used in a computer vision tasks like image classification, object recognition, and video analysis. Now this image and video processing doing a vital role in all areas, not only in healthcare or automation or security. So in all area it is doing a vital role. For that purpose it is very much useful. And coming to the image and video compression, as I already discussed, that is dimensionality reduce is used an image and video compression algorithm like JPEG and MPEG. So in the format of JPEG and MPEG it will be reduced. Okay. And the genomics, that is principal component analysis used for pattern recognition in genomics, it also used in the genomics. So these are some applications we have listed, but other than this we have many types of applications also. Here in this video we have discussed in detail about that is dimensionality reduction, what is dimensionality reduction and how it is used, also where it is applied. All those things we have discussed in detail. Thank you.